Uh, okay. Hi guys. Good evening. I see that this is your first class, correct? So maybe let us maybe get to know about each other a little bit, and then maybe I'll tell you what and all you're gonna learn in this 11th class chemistry, and then we'll look into maybe a little, into the first chapter. Like we'll not do much, but still we'll just, for the sake of it, we'll just start it and give you some introduction, right? So maybe I'll introduce myself and then I'll ask you to introduce yourself. And whenever I ask a person to introduce themselves, maybe it's better that you turn on your camera and then you introduce yourself. Okay, right, fine. So my name is Akash, right? So like most of you would have known, or if you don't know, like my name is Akash, and I'm going to teach you I'm going to teach you chemistry for this 1 year, maybe possibly when you come to 12th in Epsilon Academy. I'll be continuing there also, right? And telling about my career, I have been teaching chemistry for the past almost 7-8 years, right? I was part of Byju's. Like you must have known about the company Byju's, the Byju's app. So I was working there for 3 years, and before that, I was doing my college. I was doing my part time. When I was studying itself, I was teaching in Time Institute, and then campus interview came. So then it was Byju's, and then after that, I quit Byju's last year, and now I'm currently pursuing a PhD in chemistry. Right? In if you know the college, it is Indian Institute of Science Education, in ISER, basically Indian Institute of Science Education and Research. It's in Tirupati, right? Okay, so I'm currently doing my PhD. I'm almost 1 year completed. I'm into the research, right? So as far as subject is concerned, guys, you are in very safe hands. Okay. And regarding how the classes or how you have to conduct yourself during the classes, there is nothing much. Like I know you are not going to speak, you are mature people, you are not going to mess up with the classes, but please understand people, right? When I'm teaching, right, I am not the one who will spoon feed you, like say like what to say, take down this. Sometimes I will tell, obviously, but it is your responsibility, right? Whatever comes out of my mouth, right, literally whatever comes out of my mouth, you are going to record it down. Nobody in my class will sit without a notebook, without a pen. No, you're not going to sit. Whatever comes out of my mouth, it is your responsibility to record it. Okay. And it is I am like it, we are going to see things which are there in the book, obviously that we'll cover, and we will also see which are some things which are not there in the book, just for the sake of you appreciating the subject. Okay. Now I would ask you to treat chemistry not as a subject, right, but as learning something which is something around you, like how you can feel physics, right? Everything is around you, will be able to explain in terms of, say, whatever you learn in physics. The same way I would like you to appreciate whatever you're going to learn, and I will take you in that path. Okay, I will take you in the path, so that you will be able to appreciate and like the subject, and then eventually maybe some of you get inspired and maybe become a scientist, right? Like that's the like last step. Anyways, so I think that's enough of an introduction about me. Maybe I will ask um, like say, okay, the first name I see is Sri Sai Raghav. Hi there, Kana. You can unmute yourself and open your video and then introduce yourself.
Good evening, sir.
Yeah.
This
Good
is
evening.
Sri Sai Raghav, and I'm studying in DAV Public School, Velachery, and
Okay.
11th standard. And I'm doing the physics, chemistry, mathematics, computer science group.
Okay, that's very nice. And one more thing I wanted to know from everybody is, among physics, chemistry, mathematics, and biology, if some of you have taken biology, I want you to tell which is your favorite subject.
My favorite subject is mathematics.
Mathematics. Very nice. Very nice. Okay. Thank you, Sri Raghav. Maybe I'll go to next. Ashwath, are you there, Kana? Ashwath?
Yes, sir.
Yeah. So can you turn on your video if that's not a problem, if you're in the right place?
Yes, sir.
Yeah, good. Yes, go on.
Same, I'm studying in DAV Public School and bio group. I'm a bio student.
Nice.
I also like math.
You like math. Okay, then why did you choose biology, Kana?
I want to write
Because as far as I know, in computer science, you'll be actually using a lot of mathematics and logics. So anyways, maybe you're interested in the doctor field. Is that why you chose it?
Yes, sir.
Okay, very nice, Ashok. Very nice. Thank you. Okay. I'm seeing the next name as Raghav. Are you there, Kana?
Yes, sir.
Yeah.
Sir, I have a big
Can
problem
you?
with my camera.
Oh, sure. Okay, go on, go on.
Sir, I just joined. What should I do? Can you tell me now?
Oh, nothing. You just have to introduce yourself. Like, what's your name? Where, like, like which school are you from, and which is your favorite subject? All that. Yes.
Yes, sir. My name is Raghav. I am from
Yeah.
DAB Public School. I have
Okay.
chosen computer science stream, and my favorite subject is physics.
Physics. Very nice. Very nice. Okay. Thank you, Raghav.
Hmm.
I'm seeing next is Madhumita. Madhumita Makesh.
Yes, sir. This
Are you speaking? I'm not able to hear Kana.
sir, can you hear me?
Yeah, now I'm able to hear you. Yes.
Sorry, I was on mute. So
Yeah,
I'm
sure, sure.
Madhumita.
If you don't
DAV
mind, can you switch on the camera, like, so that I can see?
It's not
If
working,
this
sir. I
is-
have to get it right.
Oh, okay, no problem. Sure, go on.
So I'm Madhumita. I'm from DAV Public School, and I'm
Okay.
from biology stream.
Okay.
And
favorite
my
subject?
favorite subject is biology.
Biology. Very nice, very nice. Okay. So thank you, Madhumita. Next, I'm seeing Srinidhi. Okay, there.
Yes, sir. My name is Srinidhi and my computer doesn't have camera, sir, so it's not working.
Sure.
Yeah,
Okay.
sir. So I'm from computer science stream.
Okay.
Yeah, I love maths, sir.
Mathematics.
Yes.
Very nice, very nice.
Thank you.
Okay. Thank you. Next, I'm seeing is Sri Sai Raghav. I think I already spoke. Next is Tarush. Tarush. How should I call you?
Sir, Tarush.
Tarush. Okay, Tarush. Go on.
Sir, my name is Tarush and I study in DAV, Velacheri.
Okay.
I chose biology and my favorite subject is biology.
Biology. Very nice. Very nice. Okay. Thank you. Thank you, Tarush. Okay. Next, I'm seeing is Hamsini.
Hello, sir. I'm Hamsini. I'm from DAV
Hello.
Public School, Velacheri.
Yeah.
I'm
Okay.
from the biology stream. My
Hmm.
favorite subject is biology and chemistry.
Biology and chemistry. At last, one chemistry I'm getting. Okay, cool. Thank you. Okay. Next, I'm seeing Harshita.
Good evening, sir. My name is
Good evening.
Harshita. I am
Yeah.
from DAV Public School. My favorite subject is biology, sir.
Biology.
Biostream,
Okay.
sir.
Biostream. Obviously, if your favorite subject is biology, obviously you will be from biology stream. I understand. Okay. So next, I'm seeing Navya. I hope I'm pronouncing correct. Navya, is that right?
Yes, sir. Good evening, sir. This is Navya, and I am studying in DAV Public School, and I have taken bio group, and my favorite subject is biology and mathematics.
Okay, biology and mathematics. That's a very interesting combination. Okay. Anyways, nice. Okay, maybe next is Sri Giridhar. Are you there?
Yes, sir.
Yes.
I'm Sri Giridhar, but you can call me Giri also.
Giri. Okay, that's nice.
I'm from computer science group. So
Okay.
I study in DAVPS Velacheri. My favorite subject is actually 3 subjects: physics, chemistry, and computer science.
Computer science. If you have to choose one, what will you choose, Kana? Among 3?
Most probably computer science.
Computer science. That's very nice. Okay, nice. Next, whom am I seeing? Suprajit Sahu. Are you there?
Yes, sir. My name is Subrajit Sahu, and I'm from DAVPS, Balacheri, studying 11th standard. And I equally love physics, chemistry, and maths.
Okay. If you have to choose one, nothing.
I would probably choose maths and no, actually equally. I love the 3 of them equally, so I
That's
can't
nice.
differentiate between them.
That's nice. No issues.
Because both of them are interconnected, so I need to learn.
Yeah, everything is connected. We will see it actually
Yes.
when we study more in chemistry. Actually, you'll account for it. All 3 streams of science are actually connected together. Good.
Yes,
okay.
sir. Yes, sir.
Fine. I think the last one is Vaishnavi.
Yes, sir.
Yeah.
Good evening, sir. Good evening,
Yes, good
sir.
evening, Karna. Good evening.
Vaishnavi, and I'm studying in DAV Public School. And
Okay.
I'm a computer science student, and my favorite subject is maths and computer science.
Okay, that's very nice. That's very nice. Okay, that was, I think, I hope I have called everybody. Is there anyone I missed, guys? Is there anyone? I guess I think I have called everyone, right? Okay, if there's anyone, please let me know. Hamsini, did I call?
Yeah. Oh,
Oh, okay, okay, fine, cool. Right, so that was a very great introduction. I got to know about each of you a little more, and we will do more. Like I will get to know more about you as well as vice versa. You will get to know more about me as we continue with the classes, right? Okay, so guys, whatever chemistry you studied in 10th, right, is actually very primitive level. Okay, very primitive in the sense, very basic level. Okay, that jump from 10th to 11th is actually a huge jump. 11th level is very easy. Okay, 11th actually, when you compare the difficulty level of chapters in 12th and if you compare with 11th, 12th is more easier. 12th is way more easier than 11th. Okay, one big reason is that the jump, I'm telling you, right, the 10th to 11th is a big jump, but from 11th to 12th is a very small jump. That's why you will be able to manage it pretty easily. Okay, so like I hope, like I remember what are the chapters you would have studied. Say the first chapter was chemical reactions and equations, and then you would have studied acid, bases, and salts, and then you would have studied metals and non-metals, periodic table, and at last I think you would have studied carbon and its compounds. And I don't know how much, like last time, so much of your portions were deleted. So I don't know how much you have learned in all these chapters, but still these are going to form a really good basic. But even though you didn't understand or you didn't follow much in 11 or 12, I mean, you didn't follow much in 10th, we will be able to catch up, right? We will be able to do an amazing job, even if you're gonna, like, say, if you're gonna concentrate here properly on 11th, right? And let me tell you, people, right? If your 11th concepts are not clear, right? If you are gonna lag there and there in your 11th concepts, not only in chemistry, but in physics, mathematics, biology, computer science, whatever it is, right? You will find it very difficult in 12th. Right, because the basics, right, the 10th level is like way more basic, but say this 11th will make you choose your path, in the sense, if you're going to do something in engineering, or if you're going to do something in science or biology or whatever it is, right, you will be able to actually get inspired by all the topics. A specific topic, you'll be able to get inspired, and maybe that inspiration will get you to do something related to science. Right, and eventually it is going to make you score good marks, and obviously it is going to make you understand better when you come to 12th, right? So these are all the things which you have to keep in mind, right? 11th, as mark wise, or say nobody is going to ask you what mark you scored in 11th, but definitely the concepts which you study in 11th, right, will actually, if you're going to choose engineering, or if you're going to choose MBBS, or if you're going to choose science, you will see that this keeps on coming. The concepts you study in 11th and 12th will keep on coming till even you do PhD. I'm doing a PhD, right? I'm doing a PhD. Still it comes. Whatever I studied in 11th and 12th, still I use it, right? And I will eventually tell you whenever we see particular concepts, I'll tell you where are we going to use it. That question always comes, isn't it? Sir, where are I going to use it? Why are you even studying them? Right? For major of the topics, I will be able to give you an insight. Like, where are we using it? Why are you even studying those things? Right? Okay. And if someone of you is going to for say writing competitive exams, say JEE and NEET, right? Then 11th is little more important than your CBC 12th. Right, so like how to put it, like sometimes even though you don't understand certain concepts in 11th, you will be able to do something and score marks in your 12th. But if you're gonna go for your competitive exams, right, you will find it very difficult if you do not consider 11th. And obviously both 11th and 12th concepts will be included in your JEE or NEET exams, and that's how the question paper will be prepared, right? Okay, so I think that is enough about how 11th is gonna be, right? 11th is gonna be challenging, people. Let me this is not going to be a cakewalk. I'll just tell you now itself, right? It is not going to be a cakewalk, but let me tell you this: it is very interesting, right? Like if you try to little put in your mind, right, you will find that certain topics or even all the topics which you're going to study in physics, chemistry, mathematics, it's all theoretical, but still physics and chemistry, whatever chapters you're going to study, it's going to be amazingly interesting. Okay, and obviously it depends on the faculty, like how they teach it, what insights they give you. And don't worry, you are in good hands, and I'm going to at least try my level best so that you are not going to hate the subject. And I see, like in all the introduction I saw, only one of you told chemistry as your favorite subject. Let me assure you, when you complete this 11th class, right, I am going to make sure that when I ask you again when you come to your 12th, what is your favorite subject, at least most of you are going to tell that chemistry is your favorite subject. Okay, we are going to make sure that we are going to do it, right? Okay, right. So I think let us see what and all are the chapters you're going to study, right? Maybe we'll just list out the chapters, and I'll just give you a brief introduction about what you will study, right? And how I can say, how is it correlated to your 10th chapters, whatever you have studied. We will just do a little connecting dots kind of stuff. Okay, so for that purpose, I'll be sharing my screen, people. Okay, I'll be sharing my screen, and I'll be writing something for you. Yeah, I hope everybody is able to see the screen. Yes, can I get a yes? Are you able to see the screen? Okay,
yes, sir.
Great. Yeah. And our classes, people, right, are going to be very interactive. I will be asking you so many questions. What do you think? Is it correct? Is there any logic behind whatever I'm telling? Or do you propose a better explanation? Any type of question I'll be asking, and anybody can unmute if you know the answer, or even if you don't know the answer, you have a guess, you are welcome to just unmute yourself and speak. Doesn't matter whether it's wrong or right, or someone is going to think bad, someone is going to appreciate you. None of it matters. Really, none of them matters. All that matters is you participating, and I am making you participate, and so that I will learn with you and you are going to learn from me, and it's going to be mutually beneficial. That's how the classes are going to be, right? And one more thing, like this is about the questions which I ask you. Now, if you have any questions, people, like please do not think that the question is going to be a stupid question. No question is a stupid question. For you, for your understanding level, for your knowledge, whatever it is, accordingly you'll ask questions, and nobody is going to judge you. And even if they judge you, do not give a damn about it. Okay, you paid money, right? And it is your responsibility to clear the doubts as and when required, right? You are always welcome to stop me right there at that particular moment when you have a doubt and ask it. Okay, or you have the availability of chat box. Say if at all you don't want to disturb me while I'm teaching, you can always put your doubts in the chat box, and I'll look into it and I'll answer your questions. Okay, so let us make sure that it is always going to be a two-way conversation rather than me teaching and then you listening. That kind of class will be very boring for you, and it is going to be very boring for me. And I don't want a boring class, right? I hope I made my point very clear. Cool. So let me go for my OneNote. Right. So I had a page. Today is 12th. Okay. Today is 12. Okay. You are 11th, right? You are 11th, and today is 12:06. Okay, fine. Good. So let me make it full screen. Right. Okay, and one more thing, guys. I want to give you a heads up. The heads up is my handwriting is pathetically bad. Okay. Right. So I will try to write as legibly as possible. It's not like you will not understand what I'm writing, but still, if you look at it, you will find it very shabby. But it's not like you'll not understand. All the words will be very legible only. But if at all you don't understand anything right there, and you can always stop me right there and ask, sir, what is that? What did you write? All that. That's a common thing I see in my class. Okay. If it's like I am always used to teaching in boards offline. Like recently because of Corona, we moved to this online classes. So in board I'm a little better, right? But with this technology, I have a slate, like say a digital plus slate, and if I write on that, you will be seeing in the screen. So I'm getting used to it. This is just my third class I'm using this. Before that, I was actually using board. I will be using my phone camera, and I'll be using a stand and teaching you. But still, we'll try this out, how this works. Okay, fine. So I told you that we'll see what are all the list of chapters we'll be studying, right? Fine. The first chapter, which you will be studying, is some basic concepts of chemistry. Okay, right. So in this, what are you going to study? Right. So as the name tells you, you are going to study some very, very basic concepts, right? I would say this is a continuation of some chapters from your 9th class, right? You would have studied something about molecular mass. You would have studied something about atomic mass, number of moles. Does it ring any bell, people? Does anybody remember these terms from your 9th class?
Yes, sir.
Yes, sir.
Okay, most of you should be remembering. At least if you don't know exactly what are those, but at least these names should ring a bell in you, right? Say molecular mass, atomic mass, number of moles, Avogadro number. Avogadro number, I don't think you have studied, but still, right? So these are all the things. So in this chapter, what will you study is, say I have a chemical reaction, right? Say A plus B giving C is a chemical reaction. Okay, now you have to say, I'll write it actually. Say I have A plus B giving C is a chemical reaction, right? Say if I tell you that I have some X grams of B, okay, I have some X grams of B present, right? So with this, I'll be able to predict how much of A is required, right? And how much of C will be formed. So you understand, right? I am going for the quantification of a chemical reaction. Till now, what you have studied is only qualification, in the sense that, okay, if I mix this and this will be formed, right? But now we are going to delve into the concept of quantification. If I mix this much of A, and if I mix that with this much of B, okay, this much of C is formed, right? So all these stuff is what you're going to study, right? And then you will be studying about certain things called as concentration terms. I don't want to, like in the first class itself, I don't want to tell you the names, but still something I can tell you, say something called as molarity. I can write it if you want. There's something called as molarity, molality. Okay, don't get afraid, people. Like this is just an introduction class. We are not doing anything, right? So what are these? What is this molarity, and so many other stuffs are there. Say now, again, it's all about quantification, right? Say you take some tumbler, right? You take a tumbler of water, right? You mix some sugar or salt into it. Obviously, what will you see? You will see that it is going to get dissolved, right? But again, that is again a qualification. That is just looking at what exactly is happening. But if I look into how much amount of water is there, how much amount of sugar you add, or how much amount of salt you add, and that correlations, right? Well, that is what we are going to study in terms of concentration. We know about concentrated acids, diluted acids, right? So when can someone tell me what do you mean by concentrated acids and diluted acids? What do you mean by them, guys?
So concentrated acid has more amount of the salt and less amount of the liquid, or liquid part or the water part. And diluted salt is diluted acid has less amount of salt and more amount of water.
Okay, so if okay, like say overall it's correct what you said. Say you have to look into, like say if a little more include certain technical terms, I will use the term solute and solvent, right? I think these terms you are very much familiar with, right? Say solute is what is getting dissolved, right? And solvent is something which is dissolving the solute, right? Say in a concentrated solution, right? In a concentrated solution, there'll be more amount of solute. Say if it is a solute in salt or acid or sugar or whatever it is, right? In a diluted solution, you talk about more, like say lesser amount of solute and more amount of solvent, right? So again, you are just talking about this less, more, all that, but we are actually going to give numbers, right? I'm telling you, this entire chapter is all about quantifying whatever you have studied till now, right? Quantifying a chemical reaction, quantifying a solution, right? And then you will at last you will eventually see something called as titration, right? And you will be, if you go to your school this year, hopefully you will be going to your school, this will be one of the experiments you will be doing in the chemistry lab, right? Titration, right? What do you mean by titration? Titration is a process, right, in which you find the unknown concentration, right? Say I have a test tube and I have a solution with me. I know what is there. Say it is some KMnO4 or any other chemical for that matter. I have some solution with me, right? I want to know what is the concentration of this. How do I find this unknown concentration? and that unknown, again, these are numbers. Concentration, when I say these are numbers, okay, how do I find this number? That process involved is what is called as your titration, right? So these are all the overall stuff we'll be studying in this chapter, and this chapter is very, 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 very important, not with respect to marks, but if you want to understand the other chapters in 11th and 12th, right? This chapter is very, 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 very important. Some basic concepts of chemistry. Okay. Now, I didn't go anything. I didn't tell you anything about like more, like say we didn't go into the details. It's just the overall overview of what you're going to study. Okay, fine. The second chapter we will look into is atomic structure. Okay, please bear with it, guys. This is atomic structure. Okay. Now, I think from the name itself, we can understand what you're going to study, right? We are going to study the structure of an atom, right? And again, this was again your 9th class. You would have already studied different atomic models. Can someone tell me what are the different atomic theories you have come across?
Dalton theories, Rutherford model.
Yes.
Bohr's model.
Bohr's atomic model. Absolutely, absolutely. This is exactly what you're going to study again, but you're going to study it very in depth. Okay, right? Dalton's atomic theory is there's nothing like Dalton. All the postulates, atoms are indivisible. All matter is made up of atoms. All the so on and so forth. That will not concentrate much. But you said I don't know whether you remember this plum pudding model. Do you remember this, guys?
Yes, sir.
Yes, sir.
Okay, all of you will remember the plum pudding or watermelon model, or however you call it. Do you know who was the scientist behind this? The plum
Sir, I
pudding
guess
model.
J.J. Thomson.
J.J. Thomson.
Yes, it was J.J. Thomson. Absolutely right. So we will look into the experiment, what he conducted. There's something called as cathode ray experiment. Again, you should have heard it at least. If not, no problem. We'll again see it. So cathode ray experiment. So based on the experiment, then he gave his own atomic model. That is what is your plum pudding model. So we'll see the history basically. This atomic structure chapter is actually first part of the chapter is history. Okay, say from Dalton, how did we move on to J.J. Thomson? And then say J.J. Thomson was actually awarded the Nobel Prize. But you know, a Nobel Prize for what? He was awarded the Nobel Prize for what? Yeah.
It's a discovery of electron.
Yes, correct. For discovery of electron, right? And he was not given in Nobel Prize in chemistry. He was actually given Nobel Prize in physics for discovery of electron. Okay, good. So we'll study about how, with basically this cathode ray experiment, what I wrote here, with the help of this only he discovered electron, right? And after he discovered electron, he wanted to put it inside the atom, and that's where the plum pudding model came. And you will see that after that came your Rutherford. Rutherford actually found out what? He discovered one of the parts of an atom. What is
Neutron.
What did he find out?
Neutron.
No. What is it?
So the nucleus, nucleus.
Yes, nucleus. Absolutely right. Rutherford was the one who discovered nucleus, right? Actually, if you like, there is a thing. If you see, J.J. Thomson is the teacher of Rutherford. Basically, Rutherford is a student of what is that? The J.J. Thomson. So it's like student disproving his own teacher's theory. Like that's how it became, isn't it? Because plum pudding model had its own problem, right? So Rutherford gave his own model. So again, that had some failure. So then came your Bohr model, right? Bohr's atomic model, and this is what science does to you. Bohr is again a student of Rutherford. Okay, so it's like 3 generations of teachers and student disproving their own teachers' theory, right? It's like that. Okay, so again came Bohr model. We will spend so much time on this Bohr's model. We will look into the mathematics of this. You would have just studied that some postulates of whatever Bohr told. All that we'll obviously start with that, but we'll go into the mathematics. We will see so many stuffs. Okay, and then obviously Bohr model is also a problem. Can someone tell me what was the problem with Bohr model? One main drawback of Bohr's atomic model?
Sir, he said that electrons revolve around orbits.
Okay. Now, what is the problem? Okay, go on.
But then an atom doesn't have a nice boundary, so it was difficult to predict. And then came the concept of orbital.
Yeah, absolutely. Very true what you said. But okay, this is a drawback. But one main drawback is what? Okay, the main drawback was Bohr's atomic model will work only for species having one electron, like hydrogen, right? Hydrogen has one electron. Say helium plus ion. I hope you understand. Sorry, helium plus, right? Will again have only one electron in that, right? So like this kind of species, right? Or if you have only one electron in the atom, right? For those species only Bohr's atomic model will work, right? So then we will move on to like various theories, like you have something called as Planck's quantum theory, right? There's something called as Planck's quantum theory. So that he said something about orbitals, right? The concept of orbitals, actually the basics come from this Planck's quantum theory, right? You'll see that, anyways, we'll not go into the details. Planck's quantum theory will study. Then you will go to the concept of orbitals. And at last, what we are using now is what is called as your quantum mechanical model of an atom, right? So this is what we are currently using, okay? And this we will study in depth, okay? So we'll see all the history and we'll look into what exactly we are using now, what atomic model we are using now, and that is constant. Maybe if a great scientist comes up with a new model, maybe we'll follow that. But for the last so many decades, we have been following this quantum mechanical model only, right? So like we will see, like we actually, when you go to Bohr's, when you see what are all the problems in Bohr's, you will study so many scientists' say contribution. I don't know whether you have heard Schrodinger's cat. Have someone heard of it? Schrodinger's cat.
Yes, sir.
Yes, sir.
Okay, I think you must have seen at least in some English series or movies. So many times they will tell. So there'll be a box, and in that box there'll be a cat, and say the box will be filled with poison, right? So unless and until you open the box and see, you cannot predict whether the cat is dead or alive, right? So as long as the box is closed, right, the cat is in a state of both dead and alive. It's a complex thing. It's not complex. So that's what it is, isn't it? Unless until you open it, you really don't know for sure. You can tell that, say, probably say 70% chance that the cat is dead, or say you can tell the 30% chance that the cat is alive, something like that. You can talk only in terms of probability, right? And that's exactly what we'll do in this quantum mechanical model. We will speak everything in terms of probability. Probability in the sense, say at this particular point, the probability of finding the electron is say 60% or 0.6, something like that, right? So that kind of scenario will bring into. Okay, and other than that, you will be studying about dual nature of light, right? What do you mean by dual nature? I think again, some idea you would have had. Light has both wave-like properties. It is a wave. Hope you're looking at my video. It's like a wave, or it can be a mass. It can be a point, right? It has both the properties, and we will prove that it has dual nature, right? We'll prove that it has both particle nature. There'll be some experiments. There'll be some phenomena which explains that light or electron, for that matter, not only light, even electron for that matter, has both particle as well as dual nature. There'll be some phenomena which will explain all these things. We'll look into all those things, right? So these are all the things we'll be studying. Like this is one of the very interesting chapters, very, very interesting chapters, right? And again, this chapter, especially this quantum mechanical model which you're seeing here, right? If you don't understand this, you are not going to understand the concept of electronic configuration. Till now, when I say that the atomic number is 8, for example, how will you write electronic configuration? You will write like 2,6. This is how you write, right? But if now, after we finish this quantum mechanical model, this we will represent it as 1s2, 2s2, 2p4, something like this. Don't worry about it. We will see how are you going to do this, right? So we will actually, instead of having shells or orbits, we are going to go into something called as orbital. Say S is an orbital, P is an orbital. Anyways, like these are all things you'll be studying in this chapter called atomic structure. Okay, right. Now moving on, third chapter. Third chapter is periodic table. Again, you would have studied this in your 10th class, and we are just going to continue where you left. Okay, you would have studied about, like, we are not going to see the Mendel's periodic table, or before that it was Dauberni's triads, or say Newland's laws of octaves. All that we are not going to see. We are just going to concentrate on the modern periodic table, right? So we know there is something called as groups, there is something called as periods. So along the group, how the atomic size varies, along the period, how it varies, say atomic size is one, ionization enthalpies, electron gain enthalpies, these things you don't know. You like whatever trends, atomic trends, you wouldn't have studied in your 10th class, we'll be studying it in your this chapter, periodic table chapter. Right. I don't think you would have studied about this electron gain enthalpy. Did you study about this, guys? EGE, electron gain enthalpy in your 10th class?
No, sir.
Did
But
you?
No,
No,
sir.
right?
Not in
No,
10th,
sir.
sir, but in 11th.
Oh, this chapter was deleted.
No,
Was
we
this chapter
had the
deleted?
periodic classification, that chapter, but then we didn't learn about the electron gain and
Gain enthalpy. Absolutely, you wouldn't have learned. Right. So like this, there are so many other stuff like ionization enthalpy, electron gain enthalpy. There'll be say you generally know that when I go down the group, atomic size increases, but you will see some exceptions, right? Say sometimes when I go down the group, the atomic size may decrease, right? So what are all the factors, all these stuff, like little more in depth. Right? If you have a clear concept in your 10th class periodic table, you will be able to do very good in this chapter. Very small chapter, right? But this is again you will study. Okay, fine. Nothing much to speak about. You know what you're going to study in periodic table, the trends, different aspects of the trends is what you want to study. Okay, that's about the periodic classification of elements. And then the fourth, and this is my favorite chapter, is chemical bonding. Ooh, right. Fine. So you would have studied about bonds in chemistry, right? Say now you know there is something called, okay, tell me what are all the different types of bonds you know?
Ionic bond,
Covalent
covalent bond.
Covalent bond.
Ionic
Covalent
bond, covalent bond. Okay, then any other thing you know? Do you know that say something called as coordinate bond? Have someone heard of it?
No, sir.
No, sir.
Okay, you wouldn't have heard of it. Okay, fine. Do you know that there's something called a sigma bond, pi bond? Like any of these terms ring any bell? Sigma bond, pi bond? No? Okay, no issues at all. So basically, like that's what, like this is what is the knowledge you have, like say ionic bonds, covalent bonds. We like ionic bonds are very easy, isn't it? Like say there'll be one element which will lose electron to form the cation, and there'll be one element will actually accept the electron to form the anion, a positive charge, negative charge, and I'm going to have a bond. Basically, when I say bond in chemistry, it's all about the attractive force, the force which keeps two atoms together. That is what is called as a bond. Okay, fine. So ionic bonds are very easy to understand because there's a full positive charge, full negative charge, positive and negative will attract very easy, right? But when I go to covalent bonds, right, you know I'm going to have mutual sharing of electron. That's what they say, right? We will actually look into the say very inside picture. We'll go into the atom and we'll see what exactly is happening. How exactly is a covalent bond formed? There are various theories. I think one theory you would have already studied. This should definitely would have studied. That is your Lewis theory. Yes, Lewis dot structures. Did you study that?
Yes, sir.
Right. So Lewis dot structures you would have studied for different things. So we'll start with the Lewis theory, and then obviously there are problems based on that. You would have studied octet rule. Right? You would have studied octet rule for stability, or even duplet rule. You would have studied octet or duplet. Right? You would have studied. Can someone tell me what is it? What is the definition of octet rule?
The outermost shell can has only 8 electrons to be stable. Needs
correct.
8 electrons to be stable.
Understood. What you're telling is correct. Understood. Yes. For attaining stability by an atom, there should be 8 electrons in the valence shell, and valence shell is the last shell, right? Or duplet says that if there can be 2 electrons, but that works only for the first shell, right? So that is the case. But again, you will see, guys, right? You will see that there are species, right? There are species which are going to have less than 8 electrons in the valence shell, right? And there will be species that you will see that they'll be having more than 8 electrons in the valence shell. If at all, I can give you some examples. Say, take the example of beryllium chloride, BeCl2, right? Say beryllium atomic number is 4. So how will you write the configuration? 2, 2. Okay, so there are 2 electrons in the valence shell and there are 2 chlorine atoms. So one chlorine atom will give 1 electron. Correct. So there are 2 chlorine atoms. So 2 chlorine atoms will give 2 electrons. So the configuration will become 2, 4 for beryllium. I'm talking about beryllium only, guys. Okay. Now, if you look at beryllium, 2, 2 is the configuration. So 2 electrons are going to come from, that is 1 electron each from 1 chlorine is going to come. So the configuration is going to become 2, 4. Right. But what does Auckland or duplet says? I should have either 8 electrons or 2 electrons, and none of them are matching. But still, this compound is highly stable. This compound exists. Right. Now, how are we going to look into it? What kind of explanation we are going to see is because you will see that Lewis theory is not the only theory. There are various other theories. I think if at all I have to list it out, I can list it out. The various theories you'll be studying is valence bond theory, VB theory, we call it. There is something called as VSEPR theory, valence shell electron repulsion theory. And at last, you'll be going for the molecular orbital theory, right? All of these explains how a covalent bond is formed. Okay, obviously, like say these 2 are the best ones, VSEPR, actually all the 3, VSEPR, VB as well as MO. All these are very important. Right? You will be using them till you finish studying, obviously, right? So this will give you a lot of insight in so many compounds, right? So after this particular chapter, any compound they give you, right? Any compound they give you, you will be able to predict what shape or what geometry that particular molecule will take. Okay, so for example, you must have studied this, right? You must have studied that CH4. Can someone tell me what will be the shape from whatever you have learned in your 10th class? CH4, what is the shape of the compound?
Like a plus sign.
No, there's a name. I hope you would have studied. If not, it's okay. Maybe I'll tell you, at least tell me whether you know this or not. The shape is called, absolutely, tetrahedron. Right. So tetrahedral shape is something like this. If I can show you, right, 1 H here in the same plane, another H here in the same plane, and there are going to be 2 more H's that will represent like this. Okay, this is how we represent. So what does this mean? These 2, this hydrogen and this hydrogen, when I say a normal line which I draw, that means it is in the plane of the screen which you're seeing, right? It is in the same plane of the screen, right? This bond, whenever I write a wedge, right, whenever I write a wedge kind of structure, that means it is coming towards you. Okay, that hydrogen is pointed towards you, right? And this dashed line, dotted lines, whatever you see for this hydrogen, that means the bond is going inside the plane, right? That is, say, if I have to talk with respect, or if I have to talk with respect to you, it should be going away from you. Okay, this bond wedge represents that it is coming towards you, and this bond represents that it is coming, is going away from you. That's what it means. So, but like this tetrahedral shape, all these things come from the VSEPR theory. Like this is for CH4. Say, what if I have something like a PCl5 or say SF6, or you can have so many types of compounds, and all these compounds, the shape and how they look and what is the correct reason behind it. All these things we'll be studying. Right? Okay. Now, these are normal chemical bonds. There are something called as secondary types of bonds, like hydrogen bonding, Van der Waals forces. I think you would have learned, at least heard the term Van der Waals forces. We'll study about them also, right? Dipole-dipole interaction. So many stuff like other types of other than the normal chemical bonds, right? There are little more other types of secondary bonds. We call them as not so chemical bonds, but still some kind of attractive force. We'll study about them also. Okay, so this is what you will, again, this chapter is very important. It's very, 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 very important. Okay, for you to draw the structures, so for you to know the shapes, for you to talk about stability of a compound, all these things. Stability means what? Like if I keep it in the air, it should not be reacting. That is what is being stable. Stability and reactivity are opposite stuff. Is it not? If I am so stable, means what? Nothing can do anything to me. Even if someone hits me, 10 people hit me, I'm going to just sit like this. I'm so stable, right? Or like if some your friends come and call you and you don't do anything and you sit in your home, that's stability. But even before they call and you run out to play, that is being highly reactive, right? So stability and reactivity are opposite terms. Okay, anyways, we'll look into more of these in detail, don't worry. So that's about the 4th chapter. So next, 5th chapter is gaseous state, or in your book, they would have given it as states of matter. But majority, we will be studying only about gaseous state. Okay, so I think from the name itself, you can understand we are going to concentrate so much about gases, right? What do you mean by pressure? What do you mean by volume, temperature, number of moles, all these things, how they are connected for a gas, right? How gas exerts pressure, what are the different theories? There is something called as an ideal gas, right? There is something called as a real gas. The ideal gas is obviously ideal, which is not there in the universe. Real gas is what we have, right? So with this chapter, again, you will be able to understand how exactly a chemical reaction happens, right? Say one of the theories says that gaseous particles will be always moving there and there. They have a lot of kinetic energy, isn't it? Right? They'll be moving there and there. So if I have two gas molecules, they will collide with each other, right? So this collision is what is going to bring in the reaction. Okay, so like this, you will be studying all super amazing stuff. You'll be even studying about how do you convert a gas to a liquid. It's called liquefaction. Right? You will see what is the basic principle behind it. How are we going to do it? Right? All these stuff you'll be studying in this chapter. Okay, right? Fine. Now, 6th chapter is again my favorite. One of the favorite chapter is thermodynamics. Oh, like the name looks very fancy, isn't it? Thermodynamics, right? So, but it's very simple, people. You are going to study about heat, right? You are going to study about heat. Heat, I know, is a form of energy. We cannot call it as energy, but still, okay. For our understanding now, we'll call it as energy. Okay. You will study, say, why is it that when I take out ice cubes from the say freezer and I keep it outside, why is it melting? What is the reason behind it? Right? So those kind of very basic questions we'll try to answer in case of thermodynamics. You will study thermodynamics in physics also, right? So here we'll concentrate more into chemistry part. Like there you will be a lot of having derivations and stuff. Here you won't have much derivation. It's all about understanding and how do you apply heat or do something with heat with respect to chemistry. Is that what you will study? Okay. Now, with the help of, say, now you know there's something called as endothermic chemical reactions, exothermic chemical reactions. Endothermic chemical reactions are going to absorb heat. Exothermic chemical reactions are going to liberate heat, right? Say all these stuff, how, like why certain reactions are endothermic, why certain reactions are exothermic, right? And why is it that, say, when I keep, say, for example, if I have sodium, you must have seen sodium in your labs. I think you go to your labs and see it is a very soft metal. It will be very soft. Okay. Now, if you put sodium in water, it will violently react, right? You don't have to do anything. Just keep them in contact. They're going to react. But say you put magnesium or you put iron in water, right? You take an iron rod and put it in water, nothing will happen, right? We will try to understand with respect to heat, with respect to thermodynamics, how is it like this? Why is there so much difference, right? All these stuff we'll try to understand. Okay. Right, and you'll even see there are something laws of thermodynamics. There's something called as first law of thermodynamics. There's something called even a 0th law of thermodynamics, second law of thermodynamics, third law of thermodynamics. All these stuff. These are not laws. I would say these are all basically realizations. Right? Say how is it that when I take when I have say a slope, when I have a slope like this, right, and I put some drop of water. It is natural that this moves down, isn't it? It is not going to, it's going to move up. It's like, say, if you put a drop at the bottom of the slope, there is no chance that by itself, it is going to move up. Why? Why is it like this? Right? All these stuff, all the basic, whatever you have been wondering till now, right? All the questions we'll try to answer in the chapter of thermodynamics. Very beautiful chapter, Okay, right? So I don't want to break the suspense. That's why I'm not telling you much about thermodynamics. We'll see it when we look into it. Okay, next. So that's about thermodynamics. The 7th chapter is what is called as equilibrium. Okay, right. Now in your 10th class, in your first chapter, that is chemical reactions and equations, you would have studied something about reversible and irreversible chemical reactions. Did you study about them? Or at least the terms?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so we will continue with that, right? We will be actually continuing with reversible chemical reactions. Right? I mean, reversible spelling is wrong. Okay, so reversible chemical reactions. So obviously you will see that, say, I represent it like this: A giving B. Normally we write A giving B, right? This is a irreversible chemical reaction. But if I put this kind of arrow, right, it means that I'm going to have reversible chemical reactions. Okay, now you will see how to quantify them. It gives some numbers again, right? Say, I'll tell you like which chapter, right? Your first chapter is full problems, that is numericals. This is full numerical. I'm going to have some numericals here also, right? And then you will see periodic table doesn't have any numerical, chemical bonding doesn't have any numerical, gaseous state again is full of numericals, you will see. And then thermodynamics again is full of numericals problems. And then equilibrium is again going to be a lot of quantification involved, right? You will study in depth about these reversible chemical reactions, and you will see different types of reversible chemical reaction and their applications, right? Where are we going to use it, right? All this stuff you'll be studying in equilibrium. Okay, now you again, this even continues about your acid bases and salts chapter, right? So you would have studied about strong acids, weak acids, and so on and so forth. Salts you would have studied acidic salt, basic salt, all these stuff. We will be quantifying them with the help of a term called as pH. You would have again heard this term pH, isn't it? pH, like say pH less than 7 as an acid, pH greater than 7 as a base, all those stuff you would have studied. We will see what exactly is a pH, what is the origin of this, right? And how can I find out the pH of an acidic salt or a basic salt, how an acidic salt is formed, how a basic salt is formed. Can I control the pH, right? Obviously, you know, right, when I have, say for example, a weak acid plus a strong base, I know I'm going to form a basic salt. I think this you would have, we'll again look into it, don't worry, right? This is a weak, generally acid plus base will give you a salt, neutralization reaction, right? So when I have a weak acid and a strong base, obviously strong base will dominate to form a basic salt. So the pH of the salt will be greater than 7, right? The pH of the salt will be greater than 7. Now, how much it is greater than 7, right? Depends on how much of acid you add, how much of base you add. All these things matters. You will be able to bring in a beautiful connection between all these stuff. Okay, right? So the main concept of pH is very, very important. We'll study so much about pH and about acids. We're talking about strong acids, weak acids. We'll give some numbers to the strong acids. Say there's something called as Ka, acid dissociation constant. There's something called as Kb, a basic dissociation constant. All these stuff. It's all about giving numbers to whatever you've studied till now. Okay, I think I have to put my laptop in charge. Just a moment. Right. So that's about equilibrium chapter. Right. So I would say this thermodynamics and equilibrium chapter are highly related. Okay, we will understand how we may look into these chapters. Okay, so that's about equilibrium. And next, after equilibrium, I have general organic chemistry. Or in your book, it would have given us general principles and separations of organic chemistry. Something will be there. I'm not sure what is the exact name of the chapter. I don't go by the names. I just go by the content, what exactly there in the chapter. Okay. So anyways, so again, this is a continuation of your last chapter in your 10th, carbon and its compounds. Okay. Right. So if I have to give you a basic picture, people, right? So any organic reaction, you would have studied about a little bit about IUPAC naming, right? You would have studied about IUPAC naming. How do you name some compounds? I don't know, like whether that was included. Was it included last time? IUPAC naming?
Yes, sir. Yes,
okay,
sir.
so that was included. Okay, so you're studied about IUPAC naming. So we'll also look into IUPAC naming, but in a little more broader sense. right? We'll look at, say, if I give you, like, say, if I have to draw a structure like this. Right, say I'm just making it very complex. Something, whatever be the structure, whatever be the structure, we are going to name it. We are going to give some name to it. IUPAC naming we'll do. Right, and also we'll be studying about something called as isomerism. Right, do you know, does anyone know what is isomerism?
Yes,
Have you
sir.
heard the term? Yeah, what is that?
Sir, the compounds which have same structure but different chemical formula.
Okay, okay. So basically they have same molecular formula, something like if I write C5H10, this is a molecular formula.
Sorry, I
but
said the
this,
opposite way, sir. Yes, sir.
yeah, I understood what you're trying to say. Yes, right. So if you have same molecular formula, say for this C5H10, 1, 2, 3, 4, 5, or I can have something like this, right? Both of them will satisfy this, whatever I wrote, C5H10, but they are two different compounds. Okay, this phenomena is what is called as isomerism, but this is only one type of isomerism. There are almost like 5 to 6 types of isomerism. You look into all of them, right? First you look into IUPAC naming, then you look at all the types of isomerism, right? And you will be studying about, okay, now for that I have to draw a little, what to say, flow chart. Okay, guys, any organic reaction happens, right? Any organic, basically when I say organic chemistry, it's all about carbon, right? Carbon and its compounds, correct? So when I say an organic reaction, basically these chemical, whatever the carbon compounds which are there, alcohols, ethers, carboxylic acids, aldehydes, ketones, all these stuff together, they are what are called as substrates. Substrates means reactants. Okay, now this reactants or substrates will be attacked by something called as reagents. Okay, now this reagents and this substrates are going to react together to form something called as intermediates, right? And these intermediates are very unstable. Okay, that means they are not going to be staying there for a longer time. So they will do something. They will say gain something, or say they will lose something to form the final product. Okay, right. So this flowchart, why did I tell you, is because we will be studying about the reagents. What are all the different reagents we have, right? And we'll be studying substrates. I'll be talking about the naming and their isomerism. Just now I mentioned, right? I'll be talking about the naming as well as the isomerism. And intermediates, you have 3 types. What are all the intermediates? Basically, intermediate is like, how to put it? If I have, say, these two are the reactants. Now they will something like, they will together form something like this, and eventually I'll form the product, something like that, isn't it? We are just looking into, you see, what you are seeing is reactant product. That's what you see. But we are going to go inside the reaction and see how exactly the reactants are getting converted to product. Okay, that is what is called as your mechanism of the reaction. Okay, now we will try to look into all types of mechanism, all types of intermediates, and how these intermediates are getting converted to product. Okay, so this is the overall, this is again a very beautiful chapter. My say like the total chemistry can be classified into 3 types of chemistry. One is called physical chemistry. Second one is called organic chemistry. Third one is what is called as your inorganic chemistry. Okay, right. Now, what will you study in physical chemistry? I think from the name which we can understand, physics and chemistry combined together. Some say your atomic structure chapter, your gaseous state chapter, thermodynamics, equilibrium, wherever you have numericals generally, right? Wherever you have numericals, generally those are what are called as physical chemistry chapters. When you use physics to explain chemistry, right? You use the physical laws to understand a chemical reaction, or say you understand the chemical phenomena, right? All these comes under physical chemistry. Organic chemistry is this, anything related to carbon and its compounds and their reactions are what are called as organic chemistry. And other than that, any other reactions you have, say you have aluminium's reaction, any other element in the periodic table other than carbon, if you have, and their reactions and their compounds, that comes under inorganic chemistry. Okay, right? So in your say periodic table is one. Periodic table is going to be an inorganic chapter. Okay, chemical bonding is again an inorganic chapter. Okay, chemical bonding I mentioned here. Yeah, chemical bonding. Periodic table is a inorganic chapter. What else is inorganic? Inorganic, nothing, right? That's it. When you go, yeah, you have inorganic chapters coming, right? So that's about, this is what you'll be studying in your general organic chemistry. A very beautiful chapter. Okay, that's what. Why did I tell you the classification is my favorite chemistry is organic chemistry, right? Then comes physical, and the least I like is inorganic, right? Okay, there are reasons to that. Maybe when you study it, you will understand why is it like this. Okay, so that's about what is that? General organic chemistry. You'll be studying. This is a very big chapter. We'll spend so much time on this. Okay, fine. Next chapter, again an organic chapter, is hydrocarbons. Right? I think from the name itself, we can understand. We are going to study about hydrocarbons. You have studied about alkanes, alkenes, alkynes, right? You would have heard these terms. We will look into how do you prepare these compounds chemically, right? And after preparing them, how do you make them undergo reaction, and what are all the different types of reaction? And obviously, we look into the mechanism of all these reactions. We saw what is the mechanism. I showed you here, right? This is the mechanism. Reagents are producing substrate, substrate forming intermediate, intermediates forming product. Okay, so you'll be studying about all these stuff with respect to only hydrocarbons. You know, there are so many functional groups, right? Alcohols, ethers, phenols, carboxylic acids, aldehydes, ketones, esters, all these stuff, right? But we are going to study only about these three. And obviously about benzene derivatives. I don't, you wouldn't have learned about it, but still we'll look into it. Benzene is like this. Benzene is C6H6. The structure will be something like this. Something like this. Okay. But anyways, you will be studying about all of them. The reactions, how to produce them, and after producing them, how to make them undergo reaction, and what are the different types of reactions they can undergo. All these stuff you'll be studying in hydrocarbons. Okay, right. Again, an organic chapter. Next chapter, 10th chapter, is S and P block elements. Right. So this I would say is a continuation of periodic table chapter. Right. Now I mentioned to you there is like when I wrote something like 1s2, 2s2, 2p4, something I wrote. Right. So you see this S and P is what is written here also. Okay. S and P block elements. Basically, you will study, like you know, right? The entire periodic table is divided into groups and periods. So we will be studying in depth about group 1, 2, 12, 13, or yeah, 12 and 13. This is what we'll be studying. Okay, you'll be studying about, say, group 1 is lithium, sodium, potassium, rubidium, cesium. Group 2 is beryllium, magnesium, calcium, strontium, barium, right? And group 12 will be boron, aluminium, so that group. And there, I think it's wrong. It's 13 and 14, guys. I'm sorry. 13 and 14, right? So group 1, 2, 13 and 14. Right? These groups you'll be studying in detail. What are all the compounds formed by those elements? Is there any other, again, atomic trends will be general, right? But still, we'll look into a lot of what are the reactions they can undergo. All this stuff we'll be studying in this chapter. S and P block elements. Okay, right? So the 14th group is carbon family. Carbon, silicon, germanium, all this stuff. 13th would be boron, aluminium, gallium, indium, thallium, all this stuff. Okay, so you'll be studying them about them in depth, right? Okay, but this is like purely theoretical, right? We will see, like me teaching this particular chapter will be very boring. Okay, so we will try to come up with some innovative ways for us to finish this chapter. Maybe I will ask you to study and come. Maybe I will conduct a quiz, something like that. We will do something about it. S and P block elements. Okay, and other than this, you have one more chapter which I am not going to take, which you'll be studying on your own, is environmental chemistry. Okay, now this again is like environmental science which you have studied. It is not important with respect to your exams, not with respect to knowledge. It is just for you to know. That's it. Right, and the questions in your annual exam, you'll just get one question or maybe maximum 2 questions. So I would advise you to read it by yourself. And if you have any doubts, obviously I'm always available to clear your doubts. Okay, so these are all the chapters, people, starting from some basic concepts of chemistry. So if you just list it out, some basic concepts of chemistry, atomic structure, periodic table, chemical bonding, gaseous state, thermodynamics, equilibrium, general organic chemistry, hydrocarbons, S&P block elements, and eventually environmental chemistry. Okay, so these are all the chapters you'll be studying. All are amazingly good chapters. Okay, so in 11th, what you see is there is more of physical chemistry, right, and less of physical and inorganic. Okay, but when you go to 12th, you'll have more of organic chapters, right? So you're studying only about alkanes, alkenes, and alkanes here, right? You will have, when you go to 12th, you will have a separate chapter for alcohols. You will have a separate chapter for aldehydes and ketones. You'll have a separate chapter for carboxylic acids. Okay, so like this, you will have more amount of organic chapters, less amount of physical and inorganic chapters. Inorganic chemistry obviously will be a little less in both 11th and 12th. Okay, like I hope if you have any questions, you can ask me regarding any of this. Is there any question, guys? Okay, I suppose there are no questions. What is the time? Okay, time is almost, we still have almost 20-25 minutes. Maybe we will start with the first chapter, people. Right? This is just an introductory class. So I will just start some basic concepts of chemistry today. Okay, fine. Let us start. Okay, so for the sake of it, let me write the chapter name. Okay, fine. So we will start with what we already know, people, right? Say, now I have something called as atomic mass, molecular mass. There is also something called as mass number. Okay, now first things first, if I look into the difference between atomic mass and mass number, okay, first, what is mass number?
So number of protons plus neutrons.
Correct. Mass number basically is number of protons plus neutrons. Okay. Now please understand, people, mass number and atomic numbers are not same. They are two different stuff. Okay. Right. So, but eventually you will see that, okay, what I'll tell you is this mass number will always be a whole number in the sense that it will be 1, 23, 14, 17, something like that. It will always be a whole number. Okay, but atomic mass, even though they will have very close values, say mass number is 23, atomic mass can also be 23, right? But if you look into the actual data, it will be 23.8476, something like that. It can also be fraction. It can also be a decimal value. Okay, that is the first basic difference between mass number and atomic mass. Okay, mass number, the definition we all know. It is the number of protons plus number of neutrons present in a particular atom, right? Atomic mass, right? Okay, if I ask you this question, how many of you think that atomic mass is mass of one atom? Okay, let me put in the chat box, guys. Just put yes or no. I'm asking, can we, what to say, how many of you think that atomic mass is a mass of one atom? Just put yes or no in the chat box. Go for it. Okay, one no I got. Okay, no. Come on, everybody participate. Okay, I'm getting yes. No. Okay, yes. Okay, again, yes. Okay, fine. I am seeing a lot of mix of answers, yes and no. Right, fine. Now tell me, guys, what is the atomic mass of, say, I ask you, sodium? What is the atomic mass of sodium?
23.
Yeah, 23 grams. Correct. Right. So we are. So I asked you a question like, is atomic mass of one atom? Say, what I'm trying to ask you is, if I have one atom of sodium, will it weigh 23 grams? Just think about it. Absolutely not. Is it not? We know atoms are so small, right? A so small species, how can it weigh 23 grams? Impossible, right? So atomic mass, we are going to give you a definition now. What do you mean by atomic mass? Yeah, please go on.
Sir, can we measure measure the weight of or the mass of one sodium atom? Is it possible?
Yes, we'll do that. We'll not be able to measure it, but we'll be able to calculate it. That we'll do now.
Okay, so just by dividing number of atoms or something like that.
Something like that. Yes, we'll look into it. Yeah, wait for it.
Okay, sir.
It's a good question. Yeah, we'll look into it. So that means what we now understood is atomic mass is not the mass of one atom. No, just because it tells you atomic mass. Guys, just give me a moment. Just give me a moment. Guys, I'm sorry, there was some background noise. I have to go and check what was that. Anyways, right. So I just said you now that atomic mass is not the mass of one atom. It's pretty logical. Then what is atomic mass? Right. Now we will
Sir,
try
it is
to
the mass of the element.
It is mass of the element. Yeah, basically every element will have its own atomic mass. Correct. Right. So I'll try to give you a very good definition. Right. See, please understand, people. Atomic mass is a relative quantity. What do you mean by relative quantity? That means with respect to something, I measure it. I keep something standard, right? With respect to that standard quantity, I measure the quantity. Any other quantity, say it's like anything like a ratio. That's what I'm talking about. Whenever I talk about relative, whenever I choose this term relative, it is always means it is going to be a ratio. Okay, so atomic mass is a relative quantity. That means it is going to be a ratio. Ratio of what? Ratio of this. It is actually, if I divide atomic mass is equal to mass of, make some space, mass of one atom of an element divided by, now I'm going to have some standard weight. Okay, I'll tell you what is the standard weight, don't worry. So this is how atomic mass is defined, people, right? So it is not mass of one atom. It is actually mass of one atom of an element, any element for that matter, divided by some standard weight. Okay, now why are we not using mass of one atom directly? Obviously, because it is going to be a very small number. Right, and obviously measuring it is very difficult. Impossible to measure an atom of one this thing. Now maybe we have sophisticated instruments to do that, but again, very difficult, very difficult, right? But atomic mass can be, like, what to say, atomic mass is in some sense can be calculated. Okay, so how it is defined? This is how it is defined: mass of one atom of an element divided by the standard weight. Now, what is this standard weight? Okay, now in history, if you look at history, right, there were various choices for the standard weight, right? So initially they were using hydrogen's weight as the standard weight, and they were using oxygen's weight for the standard weight, right? But there were problems in all of them. Okay, we'll not go into the details of them, but as you understand that there have been so many choices, and now what we use, right? Now what we use, the standard weight we use as 1/12 of an 1/12 of mass of one atom of C12. Okay, now so if I have to give you the entire formula, this is how it will be. It will be mass of one atom of an element divided by 1/12 of mass of one atom of carbon-12 isotope. Now, it's only carbon. We know carbon. We know there is something called as isotopes, same atomic number, different mass number. We are going to take the isotope of carbon, which is having a mass number of 12. That's what I'm trying to tell you. Okay. So what is standard weight? Standard weight is 1/12 of mass of one atom of carbon-12. I'm going to take one atom of carbon, right? Whatever the weight is that of one carbon, I'm going to divide it by 12. And that quantity is what is my standard weight. Okay. Now, guys, do not go into details where, sir, will I be able to measure this? No, I'll not be able to measure this, but I'll be able to do something with respect to the calculation. Again, if you look at different books, different sites, they'll tell you different methods of all of them, but none of them is important for you. You don't have to know how is this calculated, how is this measured and all that. You don't have to worry about it, right? All you have to worry about is what is the definition of atomic mass. That atomic mass is equal to its relative quantity. Its relative quantity means it's a ratio. It's a ratio of mass of one atom of an element and 1/12 of mass of one atom of carbon. That's all you have to do. That's all you have to remember. Okay, and I'm going to make things a little easier. Okay, what are we going to do is I am going to give some special name to this big term here. Okay, 1/12 of mass of one atom of carbon-12. For telling itself, it will take 10 seconds, right? So we will not be using this term. This quantity, whatever this quantity I have, this 1/12 of mass of one atom of carbon-12, I am going to call this from now on as 1 AMU. AMU is atomic mass unit. Okay, AMU is atomic mass unit. So if I say 1 AMU, okay, that means it is 1/12 of mass of one atom of carbon. Okay, so if I have to write a proper definition for atomic mass, I give you a formula. It's very simple. Atomic mass is equal to mass of one atom of an element divided by 1 AMU. Very simple. Okay, basically again 1 AMU is 1/12 of mass of one atom of carbon. Okay, now can I give some value to this? Can I give some value to this one, like whatever the 1 AMU or 1/12 of mass of one atom of carbon-12? Can I find this value? Absolutely, we can find it. Okay, now how are we going to find? For that, I am going to introduce you to another term. Okay, that term is moles. Okay, I'm going to introduce you to this. Okay, now fine. So I don't know how many of you are Tamil people here, or how many of you don't know Tamil. Whatever it is. Say we will take some like normal example. Okay, we'll take dozen. Right. So when I say 1 dozen of banana, right? How many bananas, guys?
12.
12 bananas. Absolutely. 1 dozen of banana means 12 bananas. Right. So you see, this dozen, which we say, is a collective quantity. Is it not? Rather than we can even tell it as 12 bananas. Right. Why are we saying that we are going to use one dozen? It's because when I'm going to go for very big numbers, like say what if I have to go for 1,000 bananas, right? So at that time, for calculation purposes or say for business purposes, I go for a quantity which measures some amount of the particular compound, some amount of particular species. Okay, so like that, moles is something like a dozen. Or I don't know, like if you have gone to a local flower shop, like say if you've gone to a temple, outside the temple, you would have seen people selling flowers, right? They will tell in terms of moram. Like moram is this much. Like my hand is so big. Like if I actually keep a flower shop, I'll be in loss. Okay, because my hands are very big. Right, generally. Okay, anyways. So you will see that this entire thing is what is 1 moram, they say. Right. So again, that 1 moram can be, say, I'm just giving you a random number. Say it can be some 20 centimeters. I'm just giving you some random number. Now, why are we not calling it as 20 centimeters? Why are we calling it as 1 moram? Again, for the sake of simplicity, as simple as that. Okay. So how we have moram, how we have dozen, or I can even tell 1 pound. Like we say in news, if you see the gold rates, right, they will tell that 1 pound of gold, the rate has increased this much or decreased this much. Again, basically 1 pound is 8 grams, right? So again, you will see that we have some unknown quantities, but just for the sake of simplicity, or just for the sake of, like making things easier, we go for certain quantities like this. Okay, like that, mole is also one such quantity. Okay, now, like, how are we going to define it? Like, just like we know a definition of dozen. A dozen of anything is 12 of that particular thing, right? Like that, how are we going to define moles? Right, we are going to define moles like this, right? 1 mole of any substance, right? 1 mole of any substance will have 6.023 into 10 to the power 23 particles of that substance. For example, right? Just look, this number is very important,
Sir?
people. Yeah.
Sir, here when you say particles, do you mean atoms?
Coming to that. Just coming to that. Coming. Right, sir. Okay, right. So if I say 1 mole of any substance, it is 6.023 into the power 23 particles of the substance. Now this particle can be anything. Okay, for example, if I say 1 mole of banana, 1 mole of banana, in that how many bananas? This many bananas will be there. 6.023 in 10 to the power 23 bananas will be there. Okay, so if I say 1 mole of anything, 1 mole of pencils, right? That means this many pencils will be there, right? So now, if I talk in terms of chemistry, people, right? Now, this particles, what I have, can be of 3 types. Okay, it can be atoms, right? It can be molecules, or it can be ions. Okay, this particles I'm telling, right? So if I tell you, for example, if I tell you that there is 1 mole of sodium. Okay, now sodium is an element. Sodium element is made up of what? Is it made up of atoms or is it made up of molecules? Tell me that first.
Atoms.
Atoms. Okay, now please understand, people, when we speak about one single element, right, it is always going to be made up of atom. Okay, but when I talk in terms of a compound, so we'll come to that anyway. So now you understand that sodium is made up of sodium elements. Okay, right. So now when I say 1 mole of sodium, that means in 1 mole of sodium, I am going to have approximately 6 into 10 to the power 23 atoms of sodium. Okay, so obviously if I have 2 moles, means 12 into the 23. If I say 0.5 moles, it is going to be 3 into 10 to the power 23. Obviously that is very easy, right? If I say half a dozen, if I say 2 dozens, accordingly the number will change. Like here also the number will change. Okay, right, fine. So now if I talk in terms of compound, right? If I talk in terms of compound, for example, if I say that I have 1 mole of carbon dioxide, right? Now tell me, what is carbon dioxide gas made up of?
Molecule.
Carbon dioxide molecule. Individual, so many number of individual carbon dioxide molecules together will form carbon dioxide. Absolutely true. Right. So now what is the basic difference between atoms and molecules? Atom is a single entity. Right. Molecules, how they are formed? When 2 or more atoms combine together, right, they will form a molecule. Same way, 2 or more elements combining together to form compounds. So I remember elements, atoms, compounds, molecules. 2 elements combine together to form compound, 2 or more atoms combine together to form molecules. All things are related here. Okay, so when I say 1 mole of carbon dioxide, that means I will have, again, 6 into 10 to the power 23. Now in this case, I should not tell atoms, I should tell molecules of carbon dioxide. And obviously, each molecule of carbon dioxide, understand my very question very clearly. Each molecule of carbon dioxide has how many atoms?
3.
Absolutely, right? Each one molecule, if I take one molecule, please do not confuse between moles and molecules. Mole is a quantity. Molecule is a substance. Okay, so when I say one molecule of carbon dioxide, I have one carbon atom there. You can see here, right? One carbon atom and 2 oxygen atoms combined together to form CO2 molecule, right? So in one molecule, I have 3 atoms, right? So now how many molecules I have totally now? I have this many number of molecules, each molecule having 3 atoms. Correct. So if I ask you what is the total number of atoms in 1 mole of carbon dioxide, what will be your answer?
18 into 10 to the power 23.
Absolutely, isn't it right? So 1 molecule contains 3 atoms. How many molecules I have? I have this many number of molecules. So obviously, if I have to find the number of atoms, 6 into 10 to the power 23 molecules I have, each molecule having 3 atoms. So totally 18 into 10 to the power 23 atoms I have. Total atoms. You cannot say atoms of anything, right? You have atoms of carbon and oxygen is what is there. Okay. So anyways, now we will look into more details about this. Now we will go back to this AMU. Okay. We started all this just to understand what is this AMU. Now we know that something is there regarding moles. Okay. Right. Okay. Now please understand, people. Try to connect it. Okay, so I told you 1 AMU, we know already, I wrote it here. 1 AMU is 1/12 of mass of 1 atom of carbon-12 isotope. Okay, right. Now, there is one definition which you have to understand, right? Now, 1 mole of carbon-12 isotope, again, obviously, like from the previous definition, I know that I'm going to have 6.023 into 10 to the power 23 atoms of carbon-12. Okay, right. And there is one more thing which you have to understand, that 6.023 into 10 to the power 23 atoms of carbon-12 is going to weigh 12 grams. Okay. Now, if at all you're getting confused with this, right? If at all you're getting confused with this, okay. Now there is going to be one more definition for moles. Okay. Now, when I say mole, we already said that 1 mole of any substance will have this many particles of that substance. There is one more definition. If you want, I can tell you, right? The definition is 1 mole of any substance will weigh its atomic or molecular mass. Okay. So now, for example, if I tell you 1 mole of sodium, now look at this, look at the definition very carefully, people. 1 mole of any substance, right? Now we talked in terms of number of particles. Now we are speaking in terms of mass or weight. Okay. Now, 1 mole of any substance will weigh exactly its atomic mass or molecular mass. Okay. Right. Now, when I say 1 mole of sodium, again, I wrote it here. Right now, 1 mole of sodium, right? 1 mole of sodium, I told you 1 mole of any substance will weigh exactly atomic mass or molecular mass. So can I tell that 1 mole of sodium, the weight will be 23 grams because that is atomic mass of sodium, right?
Yes, sir.
Okay. So like this, like say for example, again, 1 mole of carbon dioxide, right? I want to know what is the weight of 1 mole of carbon dioxide. You just calculate the molecular mass. You will find that it is going to be 44 grams. Okay, right? So this is the second definition. We'll have one more definition. We'll come to that later. So for now, you have 2 definitions. One in terms of number of particles, that is 6.023 into 10 to the power 23 particles will be there in 1 mole of any substance. And second definition is 1 mole of any substance will weigh exactly the atomic mass or molecular mass. Okay, right? Fine. So why are we doing all this? Is because I'm going to find the value for 1 AMU. Okay, that is why we are doing all these things. Okay, fine. So actually this all came from assumption. These are all some standard things which came from history. Okay, so like what we are doing here is what has happened in history, right? But you wouldn't understand if I tell you that it's history. That's why we went for the modern definitions here of one mole means this many particles, this much weight, this and all. These things actually came from this, whatever I'm telling you here, right? Whatever I'm going to do now here from this, only these things came, the definitions came. The concept of moles even came from this particular thing only. Okay, anyways, but all these are correlated. You don't have to worry about how it all came. All you have to understand is what exactly is happening here. Okay, fine. So what I'm telling you is 1 by 12, 1 mole of carbon will, obviously from the definition we saw, it will have 6.023 into 10 to the power 23 atoms of carbon, right? And obviously this many atoms of carbon, that is 1 mole of carbon, will have a weight of 12 grams. Okay, now what is the time, guys? I should not be taking extreme time. Okay, I'll just take 2 more minutes. Okay, right. Okay, so now if you look into it, now look at this. It is, first what I have to find is mass of 1 atom of carbon. That if I find, okay, what is the mass of 1 atom of carbon if I find, and I divide it by 12 because it's 1 by 12. Okay, I am going to get the AMU value. So first thing is I have to find mass of 1 atom of carbon. If you find that, now after finding it, divide it by 12. So that you will be getting the entire 1 AMU. What is the value of 1 AMU? Okay, now we'll try to do that. Now what we have in hand is this particular data. That is this many number of atoms of carbon, that is 6.023 into 10 to the power 23 atoms of carbon will weigh 12 grams. I'll write it here again actually. 6.023 into 10 to the power 23 atoms weigh 12 grams. All I want to know is if I have 1 atom of carbon, what will be the weight is what I have to understand. Correct. And I don't know whether you know this, people. There is this thing called as cross multiplication. Okay. Now you see there are three things already given to you. That is this many number of atoms will weigh this many grams, and I want to know for 1 atom how much. Now whenever you have this kind of scenario, what you do is you cross multiply. You multiply this with this and this with this. That means if I keep it as x, so you have to find it. Right now, what will be x? So if it will be like 6.023 into 10 to the power 23 into x will be equal to 12 into 1. No issues. Okay, so this you can remember, people. You will be using this a law. Every question you will be using this cross multiplication, and I'll tell you how to use it when you go for more problems. Okay, fine. So I have this coming, right? 6.023 into 10 to the power 23 is 12 grams for 1 atom. How much? Weight, right? So that is what is x. So if I have to find x, x will be equal to 12 divided by 6.023 into 10 to the power 23. Okay, and this x is the mass of 1 atom of carbon. But what I want is 1 AMU, and 1 AMU can I say will be x by 12, because x is what I found out is mass of 1 atom of carbon. But what is 1 AMU? 1 by 12th of mass of 1 atom of carbon. Right. So what I do for 1 AMU, I have to divide whatever the mass of 1 atom I have, divided by 12. Right. So if I do that, can I say it will be 1 divided by 6.023 into 10 to the power 23. Right. And that's it. That is what is the value. So if we just calculate, right, I will have 1 AMU. I can just write it as 1 divided by Na. Now, Na is the, oops, sorry. Right. So Na is nothing but the Avogadro number. We call it as Avogadro number, which is nothing but this number, 6.023 into 10 to the power 23. Okay, so 1 AMU is 1 divided by the Avogadro number. You can look at the value. Value will be some 1 point something into 10 to the power minus 23. Something like that will be there. Okay, you can calculate. Yeah.
So could you repeat how x by 12 equals 1 upon 6.23 into?
Yeah, sure. So this x is here. Okay. Now, this is x, if I have to divide by 12, what will I do? I will divide this entire thing by 12. That is, this, if I 12 put it here, this will be 12. And this will go here then. And this 12 and this 12 gets cancelled. Yes, understood. Or if you are getting confused, let me write it like this. So x is 12 divided by 6.023 into 10 to the power 23. So if I have to write x divided by 12, I will write 12 divided by 1. I'll keep it like this. Okay. Now, whenever you have this kind of situation, what will you do? You will bring this here, and what will you do? You will put the denominator as a numerator and numerator as denominator. So it will be like 12 divided by 6.023 into 10 to the power 23 into 1 divided by 12. This is exactly what it means. Okay, now what will happen? This 12 and this 12 gets cancelled. So that is how I get 1 divided by the Avogadro number. Yes, understood?
Sir, wouldn't the 12 come in the numerator?
How will it come in the numerator? If I have this as 1 divided by 12, then this will go to the numerator. Yes, but this is 12 by 1.
But there's another 12 in the top also, right?
Correct. That is why it is getting cancelled. Say it is like if I ask you to divide 1 by 2. Okay, let me put it like this. 0.5 divided by 2 is how much? 0.25?
Yes,
this
sir.
is fine. Okay. Now, if I write 1 by 2 divided by 2, 1 by 2 is what is 0.5. Correct. So will you write it as, so this 2 will go to the numerator? If it goes to the numerator, what will be the answer then? 1? Correct. But if this goes to the denominator, yes, then only it will be 0.5, 0.25 again. Yes.
Yes, sir.
Okay. I think. Yeah. Very good. Right. So all you have to understand is, people, 1 AMU is 1 divided by the Avogadro number. We'll continue in the next class. Actually, I have taken almost 6 minutes extra. Right. So I think if there's any doubt, you can ask me, people, from what you have learned today. Right. We didn't see much. We just saw what is atomic mass, what is moles, and what is AMU. 3 things we saw: atomic mass, moles, AMU. 3 things only we saw. Is there any doubts anybody has in whatever we saw today?
No, sir.
Okay.
No, sir.
I hope everything is clear. I have a doubt, but not from this chapter. It's about the cathode ray experiment. Could you clear it after the recording stops? Yeah. For Raghav, I'm going to give you my number. Okay. My number is this. Okay. 8939219916. So I would prefer not calling. I would prefer WhatsApp. Okay, so whenever you have any doubts, whenever you're going through something, and if you're not able to understand or you're not able to solve a problem or whatever it is, you can always click a picture and send me to this number, to this WhatsApp, and I'll help you. Okay, so you can take down this number. And Raghav, you can, after the class gets over, you can just type me whatever your doubt is. I will clear you in WhatsApp. Is it okay, Kana? Right? Okay. I think there are no doubts, and this Raghav's doubt I'll clear in the WhatsApp. Okay, not only for that, any doubts anybody has, I'm happy to clear it in the WhatsApp after the class gets over. Okay, guys, thank you so much. It was a very lovely class. I hope this continues in all the classes which you're going to have, the interaction and the type of the dynamics, what we are doing. Let's continue with it. Okay, thank you so much, people. I'm gonna end the classroom.
Thank you, sir.
Right? Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
See you.
Thank you, sir.